Hello and welcome to a video, this time on the Mechanics 2022 constant acceleration question. So, what have we got here? Well, we've got two forces. We don't know this one, but they're applied to P, yeah? And that means that it would be really nice to find a resultant of these two forces because we know the direction it moves in, and the direction it moves in will be parallel, naturally, to the resultant of the two forces. So we've got 4 minus 1. We're going to add onto that lambda and mu. And it should equal, now it doesn't equal 3, 1, it equals some kind of multiple, scalar multiple of 3, 1 to make sure it's in that direction, it's parallel to that vector. That gives us a lovely result because 4 plus lambda is 3k, and that's just from looking at the x components, and minus 1 plus mu is k. And what we can do naturally is just plug this in here as our k. So 4 plus lambda is 3 times minus 1 plus mu. And that just rearranges into the answer because you get 4 plus lambda is minus 3 plus 3 mu, and hence 7 minus 3 mu plus lambda, okay, it's in a different order there, is correct as required. Write it in the same order in the exam to really flag it to the examiner that you have proved the right result, but you get what I mean, we can put that in any order. Okay, for the second part, this is a bit more subtle. But at the end of the day, it's asking for a distance, and this is a constant acceleration question. So it's definitely about SUVAT. Now, the other thing is they've told you lambda is 2. And if you know 2 minus 3 mu plus 7 is 0, well, you can easily rearrange that into 9 equals 3 mu. And some mu is 3. In other words, we know F1 and F2 now, because F1 is 4 minus 1, and F2, well, it's lambda mu, but we've just found out that is 2, 3. And so with this question, my first thoughts are, I know the time. I know it's initially at rest because it tells me it is up there. It's often the case. Look for little things like that in the question. And I know I'm looking for a distance, but I've only got 2 SUVAT letters, but I do have this. And so what's on my mind is F equals ma because I haven't used the mass yet, which they gave me at the start. Yeah. And so remember, F is the resultant force, so it's actually 6, 2. That should equal the mass, which is 4, times by a. So I can find the acceleration as a vector. It's going to be 1.5, 0.5. And in order to use it with these letters, it's best to turn it into a scalar. So I'm going to find the length of that vector, 1.5 squared plus 0.5 squared. And so that comes to root 2.5, I think. And so that's the acceleration, root 2.5. Now it's just a SUVAT problem. S equals ut plus a half at squared. And so I get 0 plus a half times root 2.5 times by 4 squared. And I believe that comes to 12.6 meters. And that's all there is to it. And as long as you've got it to 2 or 3 sig fig, I think you're fine in these questions. Cool. Okay. You could even write an exact form, actually, if you really wanted an exact form, half root 5 over 2 times by 16. Well, that's just 8 root 5 over 2. But that's the same as root 64. Sorry about my pooling notation here. Times by root 5 over 2. And 2.5 times 64 is root 160. But there we go, if you want an exact form. And that's all there is to it. Okay, hope you enjoyed the video. Keep up the good work. Bye-bye.